Hello statistics student, this video is for chapter 6.1, standard normal distribution. Standard normal distribution is a certain kind of bell-shaped distribution that is a special case of a general non-standard normal. So any bell-shaped distribution can be modeled by a density function y equal to e to the power negative 1/2 x minus mu over sigma squared. Is very complicated, but you don't have to remember it. Divided by sigma over 2 pi. So it's just show you that the exponential function that you learn in algebra and also pi that you learn actually is useful. It can be used to actually draw a bell curve. And underneath this bell curve area would be what you find the range of probability for x. So this is a general bell curve. If we calculate z score of any x, we would say what's z score? Z score is the standardized value of x. So anytime you have x value that is normally distributed, or actually any number that is normally distributed, you can calculate z score, which is how far away that x value is from mu divided by sigma. And it immediately tells you the number of standard deviation that x is below or above the mean. Meaning, if I draw a bell curve, the only x value I can be sure is mu, because it's right in the middle. All the other value, I have to have a scale, right? So how do I scale it? It turns out that I don't scale it by the normal like 10, 15, 5, 20, 25 like that. I scale it away from mu by plus sigma, plus 2 sigma. I think we talk about this in chapter 2 at the end at 2.7. This is minus sigma and minus 2 sigma. So a sigma is something that you use to scale your x-axis. So this is all the x value. The area is the probability. And then how do you know where your x falls into? You would calculate z-score. If the z-score is 1.2, that means it's 1.2 times of standard deviation away from the mean. If z-score is negative 0.8, that means it's negative 0.8 times of standard deviation below the mean. So you actually know where your x is by calculating the z-score. Positive means it's above the mean. Negative means x is below the mean. So every time we have an x value and we want to know how that particular x value is in relation to mu, we would use z-score, and it would tell us, 1.2 means 1.2. 2.3 means it's 2 standard deviation from the mean. 2.3 is times of standard deviation from the mean. And then if we just limit our attention to those z value, that means it talks about how many standard deviation a particular x value is. It turns out that the z itself is normally distributed. Anytime you look at a z-score, it's normal. If you plug in, just imagine you plug in a density function, mu is equal to 0 because there's no standard deviation from the mean. And then standard deviation is 1 because you would just imagine that one standard deviation is 1. So if I define mu equal to 0 and standard deviation and 1, then all of a sudden I have an x value known as z. So it is still a x value, it's still random, it's still continuous, but I call it z because it represents z-score. So this would be tells us the number of standard deviation any normal random variable is from the mean. So you would draw it this way, plug into that e to the negative 1/2 things, and you would have a bell curve. And just like the other bell curve, the total area is still under 1, but instead of mu in the middle, you have 0, 1, 2, 3 on the right side, and 0, negative 1, negative 2, negative 3 on the left side. By the time it hit negative 3, that's almost the tail end. This normal curve actually never touched the x-axis. So some properties of the standard normal is because it's a density function and also is symmetrical. So if you draw a vertical line through the 0, then area to the left of 0 would be 1/2 because the total is 1 and they're symmetrical. So you would say that this area is 1/2. The probability that I pick a negative z is 50%. And this area is 1/2. The probability of picking any of these positive z is also 1/2, 0.5. And then if I have a z value, like say for example, I don't know, 1.8 and a negative 1.8, negative 1.8 is here, right? So then they say left of z, left of z, well, actually the tail area, I would say the z is negative, and then it's opposite, so the tail end, these two should be the same because it's symmetry, right? If I have 1.8 and negative 1.8, the area underneath to the left tail and right tail are the same. So positive and negative z would have same tail area. The other property is if I know the area from say 1.2, okay, from here all the way to negative infinity, this side less than, all this c less than 1.2, I know the probability or I know the area. So this would be 1 minus this area. If this is area A, then this side on the right hand side is 1 minus it because they are complement. One is less than, one is greater than, right? So if you know the left area, you know the right area. If you know the right area, you know the left area. Okay, continue with the second part of 6.1. Find percentage, find probability. So remember, probability equal to area equal to percent. We always need to know that. If I'm looking at a bell curve, probability is equal to area between two lines, and you go to percentage, because percentage is relative frequency, which is used to calculate probability. So one way to calculate probability is just use the empirical rule that we talk about in 2.7 called the 68, 95, and 99.7 rule. Remember, 68 is the probability or the percentage of z-score between negative 1 and 1. So z is normal. So this is valid for all normal distribution. That is 1 standard deviation away from the mean. So if my z-score is between 1 and negative 1, that's 68% of it. Z-score between negative 2 and 2, 95%. And probability of z-score between negative 3 and 3 is 99.7%. So we can actually do some calculation. So we say, okay, weight of a certain dog is normally distributed with mean is 18 and standard deviation is 2. What is the z-score? So we can, from here, we know that we be very careful about this. Whenever they say normally distributed, you all of a sudden you will know that, oh, I need to draw a normal curve. Okay, the normal curve is like drawing the hair, but it would be facing down like this, but at 1 standard deviation away, it starts to face up. Okay, so we call this the point of inflection. So the middle is 18 and the standard deviation is 2. So you would say 1 mark, 2 standard deviation, and then 3 standard deviation is almost the end, right? So they're all that. And then because it's 2, so I'll add 1 standard deviation is 20. We'll add 1 more is 22. Add 1 more is 23. So this is 1 standard deviation, 2 standard deviation, and 3 standard deviation. And here I would minus 2 is 16, minus 2 is 14. Oh, not positive 14. And then minus 2 is 12. So again, it's minus sigma, minus 2 sigma, minus 3 sigma. So here, what is the question? What is the z-score of 14? Well, I know 14 is here. So 14 is 2 standard deviation from it, but I can actually calculate. Is 14 minus 18 divided by 2. So that is negative 2. We know it is negative 2 already. And what is 22? So C of 14, C of 22 is 22 is always start with the x value minus 18 over 2. So in this case, it's negative 4 over 2 is it's 4 over 2 is 2. So what is the probability that this dog is between 14 and 22? So it's from 2 to negative 2 is what? 2 standard deviation for the 68, 95, 99.7. So 1, 2, 3. So it's 95%. We would say they have 2 and negative 2. So It's 95%. Between these two values, is 95%. That means I know this area is 95%. Okay. And then we have B. What is the C-score of 20 pound and 16 pound? So C would be 20 minus 18 divided by 2. Oh, that's just 1. And then C equal to 16 is 16 minus 18 divided by 2. This is -1. So between 1 and -1, that is 1 standard deviation away. So that would be 68%, the first one. C score of 24 and 12. So do we have 24 and 12? Oh, actually this is not 23, it's 24. So 24 and 12, you know that it's 3 standard deviation away, right? So we can, oh, I don't have enough space here. We would say 24C equal to 24 minus 18 over 2. That is 3. But the other one, C, is 12 minus 18 over 3 over 2. Gosh, over 2. That is -3 because it's -6 over 2 is -3. So 3 and -3 between is 99.7%. It's always between. Okay, it's always between. The empirical rule does not allow us to calculate x greater than something or less than something. So the next topic is about finding probability of C-score. That is, there's not 1 standard deviation, 2 standard deviation, or 3 standard deviation in between, but more in general, that is less than a value. The value can be 1.2, 1.34, any z value. And so we would want to do the probability of z-score in standard normal. That is in between the area outside the left less than A or greater than A. Okay, so the way to do this is to use the online statbook normal calculator. I have it open here. The normal distribution. So you get to it by Googling online statbook calculator normal distribution, normal calculator. So maybe I'll try that. Online statbook normal calculator. And usually the first one that shows up would be it. So it would have the normal curve. Our familiar with 0, 1, 2, 3, because by default it's graphing the z normal. So if you get to the normal calculator from the beginning, it will show mean is 0, standard deviation is st. That means this is not x but z. Okay, so to find x less than something, so or z is less than something, right? So these are the less than z. So you would say is below z. So you use below. To find c, so this is 1.96, right? To find c is greater than 1.96, we do above. So all these z values are greater, so we just click on it. And you can do in between two number. You can also do outside two number. So you can get any number. In this case, they are symmetrical, but you can really do any number in between. So you can say 1.6 and -1.2, 1.7, and then do recalculate. Okay. Oh, we have to say in between first. Recalculate, then you'll get the answer. Okay. So remember to recalculate, and you pick above, below, between, or outside. So depends on the graph of z that you're talking about. So I'm going to stop here, and I'll do the example in the next video.